Assalamualaikum and hi everyone. Today we will do an exercise for a single phase uncontrolled half wave rectifier with RL load and also RC load. But we will start with RL load first, okay? Okay, for the half wave rectifier with RL load shown in the figure here, if Vm equals to 169 volt, R equals to 100 ohms, L equals to 0.04 Henry, omega equals to 314 radian per second, and beta equals to 4, determine the current expression I omega t, and then the average current, the RMS current, the power absorbed by the load, and also the power factor. Okay, to find the current expression of the circuit, first we need to determine the impedance Z, theta, and also omega tau first. Okay, so by substituting all the parameters in this formula, okay, we will get Z equal to 100.79 ohms, and then theta equal to 7.16 degree, which equal to 0.12 rad, and then omega tau equals to 0.126 rad. Okay, so after getting the value of the impedance, theta and omega tau, now we can substituting it into this equation. Okay, so we will get this one. Okay, but bear in mind that for the theta here, okay, if you use a radian, value in radian, so all the values must be in radian as well. Okay, and if you are using a degree, so all the values must be in degree. Okay, it must be the same. Otherwise, you will get a wrong answer. Okay, so simplify this one. So you will get 1.68. Okay, so this is the final expression for the current. Okay, this is actually during the on condition. Okay, for the average current, it is given by this formula. But don't worry, you can just use your scientific calculator to solve this problem. Okay, so by substituting all the parameters that you have, so you will get 1 over 2 pi times 2.963 m. So this is actually from here. Okay, so finally you will get 0.467 amps. Alright, and then for the RMS current, it is given by this formula. But again, you can just use your calculator. Okay, and for this one, I leave it to you as your activity. Okay, so I will check with you guys later. Okay, after you got the answer for the RMS current, okay, only then you can calculate the power absorbed by the RL load using this formula. Okay, and also for the power factor using this formula. Okay, but for the power factor here, make sure you are using a voltage source for the VRMS here. Okay, otherwise you will get the wrong answer. I will check the final answer with you later. Okay. Okay, now let's continue with RC load. Okay, so here we have a single phase half wave rectifier with RC load with 240 volt source at 50 Hz, R equal to 330 ohms, alpha equal to 45 degree, and C equals to 100 microfarad. So the question asks to determine the output voltage expression, the peak-to-peak output voltage variation, the peak diode current, the new capacitor value if delta Vout is 2% of Vm, and the new value of ID peak. Okay, for the first question, we need to determine the output voltage expression, which is given by this formula. Okay. So to solve this, we need to calculate for the Vm and then V theta and then theta and also omega RC. Okay, and for the alpha, let's convert it from degree to radian first. So we get alpha equal to 0.733 rad. Okay, but actually it is up to you. Either you want to use it in degree or radian. But as for me, I prefer to use radian. Okay, then for Vm, we need to multiply it with sub2 here. Okay, as the voltage source is in RMS value. So we will get Vm equal to 339 volts. Okay, and then for the omega RC, we will get 0.369. Okay, and for the theta equal to 1.67 rad. Okay, but for this one, make sure you get the positive value of the theta, because if you get negative, it means that you have choose the wrong formula. Okay, and finally for the V theta, we will get 337.3 volts. Okay. Okay, then by substituting all the values that we have calculated just now, we will get the output voltage expression as shown in here. Okay, and then for the peak-to-peak output voltage variation, it is given by delta Vout equals to Vm multiplied with 1 minus sine alpha, where alpha is 0.733. So we will get delta Vout equal to 112.17 volt. Okay, next for the peak diode current, it is given by Vm's multiplied with omega C cos alpha plus sine alpha over R, and we will get ID peak equals to 16.05 milliamps. Okay. Okay, then if delta Vout is 2% of Vm, so 2% of Vm means 0.02 Vm. So 0.02 times 339 equals to 6.78 volts. Okay. And then to calculate the capacitor, the new capacitor value, we know that delta Vout equals to Vm over FRC. Okay, so rearrange them, we will get C equal to Vm over Fr delta Vout. So we will get okay, so the new capacitor value is 3.03 milliamps. farad. Okay, since we have a new value for the capacitor here, we also need to calculate the new value of ID peak as well as for the alpha. And we know that delta V out equals to Vm times 1 minus sine alpha. Okay, so rearrange them, we will get alpha equal to 1.37. Okay, now we can calculate the new value of ID peak. So by substituting all the parameter values that we have, we will get the new ID peak equal to 65.38 amps. Okay, so that's it for the single phase half wave uncontrolled rectifier with RC loads. For more info and understanding, you can go to this power electronics books. Alright, so that's all for today. Thank you. Bye bye.